Hi everyone, in this video we'll take 3 examples about how using the squeezing theorem. And the squeezing theorem tells us if the function f is between g and h, and g and h goes to L when x goes to c, then f of x goes to L when x goes to c. In part A, we have the function g bounded between the two functions 4 and x to the 4th plus 2x squared plus 1. Let's say that 4 is the function f of x and this function is h of x. Now, using the squeeze theorem, since you want to find the limit when x goes to 1, you have to replace 1 by the function f, and since the function of x is constant, this means f of 1 equals to 4. And if you replace 1 in the second function h of x, so h of 1 equals 1 to the 4th plus 2 times 1 squared plus 1, and this is equals to 4. As you see, f of x goes to 4 and h of x goes to 4 when x goes to 1. And by the squeezing theorem, and since the function f is bounded between these two functions, this means that limit g of x when x goes to 1 equals to 4 using squeezing theorem. Now for the second part, as you see, if limit absolute value of x minus 3 less than or equal to absolute value of x, find limit of x when x goes to 0. Firstly, you have to use this inequality. If absolute value of something less than or equal to numbers, so this something will be between negative the number and the number itself. So by applying this property of absolute value, you will get that f of x minus 3 is between negative absolute value of x and absolute value of x. Then if we add 3 to all sides, you will get 3 minus absolute value of x less than or equal f of x less than or equal 3 plus absolute value of x. And as you see, f of x is bounded between two functions. The first function is this function 3 minus absolute value of x, and let's say that this function is g of x, and 3 plus absolute value of x, let's say that this function is h of x. And since you have to find limit when x goes to 0, you have to replace 0 by the two functions g and h. So g of 0 equal 3 minus absolute value of 0, and this is equals to 3, which means g of x goes to 3 as x goes to 0, and replace 0 in the function h, so h of 0 equals 3 plus absolute value of 0, and this will give us 3. So h of x goes to 3 as x goes to 0. And since f of x is between these two functions, this means that limit f of x when x goes to 0 equals to 3 using squeeze theorem. Now for part C, you have to use the same method used in part B. So here we have absolute value of f of x plus 8, and using this property of absolute value, you will get that f of x plus 8 is between negative absolute value of x minus 5 and absolute value of x minus 5. Then you have to add 8 to all sides, So So sorry, subtract 8 from all sides. You will get f of x as the middle function is between negative 8 minus absolute value of x minus 5 and negative 8 plus absolute value of x minus 5. Now let's say that the function here is g of x and the function here is h of x. Now you have to replace x equal 5 in both functions, so you have to find g of 5, and it will be negative 8 plus absolute value of 5 minus 5. Here we have 0, so the answer will be negative 8. So g of x goes to negative 8 as x goes to 5, and you have to plug in 5 in the second function h of x. So h of 5 is equals to negative 8 plus absolute value of 5 minus 5, and this gives us negative 8, which means that h of x goes to negative 8 as x goes to 5. Now since f of x is bounded between the two functions g of x and h of x, and using the squeezing theorem, this tells us that limit f of x when x goes to 5 equals to negative 8 using squeezing theorem. And that's it. Thank you.